Okay, this is lesson 116, secant, cosecant, and cotangent. It's just an extension of SOHCAHTOA, so trig functions, but they are the reciprocals of those functions. Does anyone know what reciprocal means?
You flip it.
Yes, good memory. You flip it. And so we're flipping sine, cosine, and tangent ratios. And when we do that, they are called cosecant, secant, and cotangent. All right? And so let's go through which one goes with which. Down here below cosecant, we're going to write sine theta, because that's going to be the flip of that. Now, does anyone remember the ratio what over what gives me sine? As far as, very good, O over H. So what would be the flip of that?
H over O.
Very good. So up here, we're going to write H over O. The next one we're going to talk through is cosine theta. What over what?
Cosine A over H.
Very good. A over H. So what is the reciprocal of that?
H over A.
H over A. We just flip it. And then lastly, we have tangent theta, which is what over what?
O over A.
O over A. And what is the reciprocal? A over O. So that's all you have to remember is that cosecant, secant, and cotangent are the flips. They're the reciprocals of these right here. Now let's apply it to a diagram. So we'll look at this diagram right here. The instructions tell us to find the value of the secant, cosecant, and cotangent of theta in the triangle. So what have I always made y'all do first?
Label H over.
Very good. Label H for the hypotenuse, O for the side across from the theta, and then A for the adjacent side to the theta.
Has no numbers.
All right? It has no numbers, but we're going to use for now the letters, the variables that go with those.
So the letters
Okay.
would just be in our answer.
Very good. All right, so let's start we're going to go in these orders so we can keep our notes consistent. So I want you to write cosecant theta, and we already agreed that that would be hypotenuse over opposite, so H over O. So tell me the letters that go with that.
C over B.
C over B, because we have H over O. So that's C over B. Good job. All right, now let's move on to secant theta. Harper, when you're ready, you tell me what to write as far as what over what.
C over A.
C over A, and she's correct. Because we know secant theta is H over A, we're going to look for the H over the A, which is C over A. And then lastly, we have I'm in the habit. I should have written cotangent theta. Logan, what did you get for that one?
A over B.
A over B, and he's correct as well because cotangent is A over O. So when we look at the diagram, here's our A, here's our O, and so it's A over B. All right, down here, they have assigned values to each of those variables. So now we're just going to write the numbers and plug them into these variables right here.
Would we reduce?
No need to reduce.
Okay.
So cosecant theta, we said was C over B. So if C is 97, we're going to put that on top. And then over B, which they said was 72, so we're going to put that on top. And that is our answer for cosecant theta. All right, Thomas, tell me what you get for secant theta by assigning the values.
97 over 65. 65.
97 over 65. He's correct because we said C over A. C over A. All right, Harper, back to you for cotangent theta. 65 over 72. She knew that it was A over B, so we had to put our A, 65, over our B, 72, and that's how she got 65 over 72. All right, time for us to do a word problem. Application, right here. It says the distance between Diane and Allie's home is 4.5 miles, so you can see that right here in the diagram. It says the cosecant theta equals 2.66. This is super valuable because it's going to tell us what is set it equal to. And then it asks, how far does Noah live? So here's Noah. From Diane and from Allie. Round your answer to 1 decimal place, the nearest tenth. All right, what is the ratio again for cosecant theta?
H over O.
Yeah, cosecant theta is equal to H over O. All right, well, let me label, like I've always taught y'all to do, the hypotenuse, the opposite, the adjacent. Remember, they gave me an answer to plug in. So if cosecant theta equals 2.66, let's plug that in and substitute it in for cosecant theta. So I'm replacing this with what they told me it equals. Now I got to, go ahead, Thomas.
Wouldn't we also just use 0? O, and that would be 4.4, right? So then it'd be H over 4.4.
H over 4.5.
5, yeah, equals 2.66, right?
Yep.
And then just do the math.
Just do the math. So I got to get rid of the 4.5 by doing what?
Times in it.
Very good. Multiply both sides by the 4.5. Plug that in your calculator. Tell me what you get for H.
12.1.
12.1. I got an exact 12.
Well, it's such a round.
Round to 1 decimal place.
Times 2.66 would be 12.
Yeah, 12 miles is what I get over here for Noah to Diane. Well, looking at this is a right triangle, is it not?
Mm-hmm. Oh, just Pythagorean.
Yeah. Tell me what to write for Pythagorean to find the distance between Noah and Allie.
4.5 squared plus x squared equals 12 squared.
Perfect. Punch those in for me.
20.25 plus x squared plus 144. Then do 144 minus
1.25
20.25
square root.
be 123 and these squares.
So it's 11 miles.
This time I actually got 11.1
Yeah.
Well, yeah, but then you round it.
to 1 decimal place.
11.12429.
So this one's 11.1.
Maybe the motto, am I right?
Mm-hmm.
Okay, good question. You said, how did we know that cosecant was H over O, you mean?
Yeah.
So H over O? Because cosecant is the flip of sine. So since sine is O over H and cosecant is the reciprocal, we flipped the O over H to be H over O. And so we used that down here. Since they gave me this info, I knew to use this trig function.
Will they always give you like the cosecant?
If they don't give you this information, I would just use SOHCAHTOA, sine, cosine, tangent. But because they were so specific and they told me exactly what they wanted, I knew to put this down here, start with this, and then put the 2.66 in its place, and then use these over here to plug in here. All right, any lessons before we move on?
Lessons.
Any questions?
Any lessons?
Can't think of any, boss.
Okay, let's move on. Last lesson of the day. This is lesson 117, determining the line of best fit. Now, first of all, does anyone remember what we call these things?
9 segments.
Good try.
Ratios?
Graph.
They're actually called
Plots.
scatter plots. Write that down. These are called scatter plots. And what we're learning today is called line of best fit. So write that down over to the right side of your page. I normally have fill in the blanks for you, but it must have fallen off somehow. The line of best fit, there's two things I want you to keep in mind. It comes close to all points in the data set. So that's bullet point number 1 that I want you to keep in mind. And bullet point number 2 is that we use these to make predictions. So one day when y'all become super rich, whether you're a business owner or whether you invest in a lot of stocks, you're going to use these to make predictions and make decisions with your money. All right, let's look at these 3 examples below, and you and I are going to determine whether or not these are good examples or not of the line of best fit. And yes, Thomas, you're right. The answer is C. But let's analyze each of these, please, just for note-taking purposes, and write the stuff down even though you're tempted to not. All right, let's look at example A. It is not a good example of a line of best fit because although it has correct slope,
It's just below all of them.
it doesn't go through the points. Right? So correct slope, but doesn't go through the points. For B, the slope is too steep. Slope too steep. So it's not the correct slope, right? And it only goes through a few points, not all. That's why earlier I capitalized ALL. And then, like Thomas so astutely recognized, option C is the best line of fit. Why? Because it goes through all points. Goes through all points. Okay, real quick up here, I forgot to explain something. So, do y'all notice the 2 things we're comparing? Arm span and height. Now, I'm not super versed in the sports world, but apparently arm span and height have a relationship correlation, like maybe with basketball players or something. So when you look at their stats or whatnot. Yeah. And so you can see that as arm span increases, height increases, meaning notice how it's going up and to the right, right? So there is a positive slope, and the dots are really close to the line. So it's a really strong relationship. So what we would say about this is that it's a strong positive. Okay, strong positive. So now look down here. We're going to analyze the correlation. That's the wording you're going to see on your homework questions. Describe the correlation between time and distance. Okay? Well, the correlation is, first of all, what kind of slope is this?
Negative.
Thank you. So because it's negative slope,
It'd be negative weak slope.
and the dots are far away, right? So weak. And we're going to put dots far away from line. just so when you look back at those notes later, you can remember. So it's, like you said, a weak negative.
So the next one is strong negative.
First, let's draw the line of best fit. So as best you can, stay with the same slope, but as close to the dots as you can.
Mine's the curvy line.
I just made a triangle.
And then, Thomas, what did you say it was?
I said strong negative line.
Strong negative. Do y'all see how he got that? Why is it strong?
Because it's going through the dots.
Yeah, the dots are really packed tight.
And it's negative because it's going that way.
Very good. It's negative because it has a negative slope. All right. That's the end of this lesson.